Okay, it's Mr. Gillum again. Today we're going to do Notes 2.4, Day 1, Quick Graphs of Linear Equations. So let's get right into it. Let's talk about slope again. The variable m is always used to represent slope. And we can represent slope two ways. Either the rise over the run, or we could say the slope is equal to y2 minus y1 over x2 minus x1. Now, sometimes the bottom one is also referred to as the change in y over the change in x. Okay? So let's just get right into it here. The new concept we're going to learn about today is the intercept. And when I say intercept, I'm talking about where the line crosses the axis. But specifically, today I'm going to talk about the y-intercept. And that variable that we're going to use for y-intercept is going to be b. Okay, that's really important, knowing that m is for slope and b is for y-intercept. Okay, the point at where it crosses the y-axis. So if we had a graph up here, like such. And we said, okay, here's my graph. Here's my x-axis and my y-axis. If I drew a little line on there, like so, I could say that this point where it crosses my y-axis is my y-intercept. Okay, my b value. If it's at 1, then b would equal 1. Okay, so that tells me my y-intercept, the b value. If you are given a graph, okay, and let's just go ahead and draw one in here. I'm going to make it as straight as I can get it. Alright, and I just put a little arrow there. If I make something like that, I can say, how would I find the slope and y-intercept of this line? Okay, what we know about slope is, what we've practiced before, is y2 minus y1 over x2 minus x1, but there's got to be a better way. So what you found just at the very beginning of the notes today was that slope is also equal to rise over run. So what we can do is this. We can pick 2 points. Let's say this point and this point. It doesn't matter which ones. But I know if I want to find the m value, or the slope value, it should be equal to the rise over the run. When I go from left to right, just like I'm reading a book, and I start at my left point, I can say, what is the rise to the next point? I can count. 1, 2. The rise is 2. So if I'm looking for my slope, I could say it's 2 over, and I could find my run. How far does it go left and right? I'm going 1 over in the positive direction, so over a positive 1. My slope could be 2. My y-intercept is a little trickier. All you have to look at is where the line crosses the axis if you're given a graph. And in this case, it looks like it passes the graph. The graph passes through the y-axis at the point 0, negative 1/2. So I could say my b value, or my y-intercept, okay, it's always represented by b, is equal to negative 1/2. Okay, so there's one example of how to find the slope and the y-intercept when given a graph. But let's do another one. Let me try to get another good clean example up here. Let's go with this line. And this line happens to be going the other direction. Hopefully you recognize this as a negatively sloped line. And I need to find, just by looking at the graph, the slope and the y-intercept. Now, just like what we just did, we now know that the slope is also equal to the rise over the run. So without doing any math, any algebra, we can find 2 points. I'll just pick him, and it looks like him. And I can figure out, well, how much did it rise from the first point to the second point? And I always read my graphs from left to right. I'm going to say, all right, if I'm going from this guy down here, I'm going to rise 1, 2, 3. I know this distance is a 3, but it's not just any 3, it's a negative 3, because I moved down on the graph. So the rise would be negative 3. From my new position, I'm going to move over, I'm going to run 2, and I'm running in the positive direction, so I could consider that a positive 2. Okay, so to calculate my slope, all I do is just count the spaces up and down, count the spaces left and right, and make a fraction, rise over run. And that's my slope. I've done all the calculating I need. M equals -3/2. But now my B value, my intercept, my y-intercept, okay, please be careful here. As you can see, this line crosses both the y-axis and the x-axis. When I'm looking for a B value, I'm talking about where does it cross on my y-axis. And as you can see, it crosses here at 1, 2, 3, at +3, so I'm going to consider my B value to be +3. Let's do just one more. And I'll graph another little line on here. Let's go with this guy right here. Okay, I have a new graph up here. Hopefully everyone recognizes this as a positively sloped line. First things first, let's find our slope, our M value. It's rise over run. Okay, so let's just pick 2 points. I noticed that there's one right here, and I noticed there's a point here. So let's calculate the rise. How far does it go up to go to the next point? Well, if I count up there, I notice that that's 2 in the positive direction. My rise would be 2. And if I count over from my new position, I count over that that's 1, 2, 3 spaces in the positive direction. So my slope could be considered 2/3, just by looking at the graph and not doing any math. Okay. Secondly, my y-intercept, my B value, is represented by where it crosses the y-axis, the vertical axis. I notice that it's at -2, so my B value is at -2. It's just that simple. You need to find the slope, M, and the y-intercept, B. When given a graph, you can just count and observe where it crosses the y-axis. Okay. Now we get into a really handy method of graphing lines. In fact, it's going to save you so much time rather than doing a t-chart. So what I want you to do is write this down, y equals mx plus b, because this is the key to the chapter right here. This is called slope-intercept form. And if you notice, in the equation, there is an m and there is a b. Okay, and that is going to be huge for us, because now that we know slope is rise over run, and we know that b is just where the intercept of the y-axis is, we can just go right to town on these graphs. If it asks us in the first equation here, what is the slope and the y-intercept? Well, if you look up here in our given, our slope-intercept form, we know that if there's an x over here, and it's exactly in the same form, the number in front of the x is the m, the slope. So we could say the slope is 2/5. And if we're looking at the same equation, the y-intercept comes after the x. So the number that comes after the x is +4. So b could be +4. We found the slope and the y-intercept without any math again. Once again, this equation, the second equation here, is in slope-intercept form. The m is in front of the x, and I know the b is after the x. That means the slope is in front of the x. M must be 1/2, and the y-intercept must be -3. The b value is -3. Finally, let's do one of these little trickier ones. We need to find the slope and y-intercept of this guy. Just like every other one, if it's in y equals form, with the x coming first, we know that the number in front of the x must be the slope. M must be equal to -2. But the problem is there's nothing out here for my y-intercept. So if there's nothing out there, and we're not talking about multiply, we could add or subtract 0 from -2x and still have -2x. So what we can say is the b value is 0 if there's no b value. The b value is equal to 0. But they might even try tricky even more and say, oh, well, what's the slope on this guy down here? What is the slope? What is the number in front of this x if it's in slope-intercept form? And we can look at the equation and tell what the slope is. There's no number here, but we know, because we're clever math students, that 1 times x is the same as x, and so the number in front of x, which is really not there, is really a 1. The y-intercept is present, it's the number after the x, the b value is -2. Okay, so that's how you could find the slope and y-intercept if you have an equation in slope-intercept form. Okay, today we're going to start graphing in slope-intercept form. So what we're going to do is we're going to be given an equation. It's going to give us the b value right in the equation. It's going to give us the slope right in the equation, and we won't have to do any math at all because we're going to start at our b value, use our slope to find another point, and connect the dots. And once our line is continuous, we're done. So let's take a look here. It tells us to find an equation and graph the line. Well, we know now that y equals mx plus b is the equation of a line, and they give us the m value, 3, and they give us the b value, -2 or plus -2. I prefer -2. Okay, but we got to graph it, and the only way we know how to graph it so far is by XYT charts, but there's got to be a faster way. So what we're going to do is this. We're going to say, okay, this is good. We know the b value actually represents where it crosses the y-axis. So let's just put it there. Let's just put our first point there. And we know that the m value, the slope value, is given to us too. It's 3. The slope is 3. But really, we know that we need a rise and a run, so we could call that 3/1. So from this y-intercept here, I know that it should rise 3, +3, and run 1. Right there. There should also be a point there. And without doing any math at all, I have my 2 points, and I made my line continuous. I have a graph. Okay, so let's take a look at another one here. It says write the equation and graph the line. My standard form of an equation, y equals mx plus b. That's slope-intercept form. Y equals m, we know is -1, x plus, and we know b is 3 this time. This is good. This is an equation in slope-intercept form. To graph it without doing a t-chart or any other work, we know that because this is a b value, we know that is an intercept. So we could start at +3. And we also know that the m value, they tell us, is -1, which is awesome because now I know if I need a rise over run, because we know slope is equal to rise over run, I can make this into a fraction. I can say this is rise over run. I can start at my intercept and I can say, okay, it rises -1, so I'm going to go down, and it runs a +1, so I can go over. And as you can see, I got my 2 points. All I got to do now is connect my dots. It's so much quicker than a t-chart, this little trick. So let's do one more just to get the good practice in. Let's say y equals mx plus b. If I want to write the equation, I can say, okay, y equals m is -2, x and b is -1, so I'm going to go ahead and put -1. I have my equation. That part is done. However, I still need to graph it. Once again, I'm going to start at my y-intercept. I can see it right in the equation. My b value is at -1. And my slope is in front of my x is -2. But really, I want rise over run. So I can make my -2 into a -2/1. So I know where I'm going. I know I'm rising -2. And I'm running a +1. Once I have my second point on the graph, I can connect the dots, make my arrow continuous, and I have graphed the line. Oh, let's do one with a fraction in it. Be very careful here. When y equals mx plus b, and we know that m is a fraction, you must write it in the form -3/2, and x must be either even with the fraction bar or above the fraction bar. This is not good. This is not the same thing. It is incorrect. Okay? It needs to be, the x needs to be even with the fraction bar or above. Plus my b value, 1. Once again, I have a slope and a y-intercept. So let's graph this thing. We know that the y-intercept is where it crosses at the y-axis. So let's put our first point there. And we know our slope is -3/2. It's where we can go from there. So let's go ahead and start at +1 and go down 3 and over 2. There we are. There's our second point. We'll graph him, put lines on him, put rays on him. He's continuous. He goes on forever in both ways. We're done.